Hi, this is Victor and welcome back to my math tutoring channel. In that video, we'll be solving that integral. This is one of the most difficult integrals because we will be using partial fraction decomposition, we will be using completion of a square, and we will be using trigonometric identity, and we have to use the trigonometric integration. So if you understand that problem, you understand most of the integration problems. Like if you know how to solve it, I won't be worried about you in the exam, and I will explain it step by step, so please pay attention. So if I look at that integral, I see it's composed of tan of x and sec, actually this is sec square of x, not to the power of 3, and sec to the power 2 of x dx, yeah? And I know that the derivative of tan is sec to the power of 2x. So that make my life easier. So I say let u equal tan of x. Then my du would be sec square of x dx. Yeah. So now I can replace my tan by u and my sec square of x dx by du. So my integral become u square plus 2 divided by u to the power of 3 plus 1, and my sec square of x dx become, let's take out this, become du. Yeah? And if I look at my denominator, u to the power of 3 plus 1 to the power of 3, because 1 to the power of 3 is 1, look like a to the power of 3 plus b to the power of 3, which is equal a plus b. My formula is time a square minus ab plus b square. And in my case, my a is u and my b is 1. It will be equal u plus 1 times u square minus u times 1, which is u, plus 1 square, which is 1. So I can rewrite my integral as u square plus 2 divided by u plus 1 times u square minus u plus 1 du. Okay? And now I can do the partial fraction decomposition. So my u square plus u divided by u plus 1 times u square minus u plus 1, I can write it as a divided by u plus 1 plus bu plus c divided by u square minus u plus 1. For those of you who does not know how I came to that formula here, I have a video, it is called the partial fraction decomposition, in my YouTube channel that explain exactly how you come to that formula. Because this is a long problem, I don't want to explain it. But if you look me up in YouTube, my channel name is Vic, the math tutor. One word, and it is attached. It's not detached. If you look at Vic the Math Tutor, you will see all my videos, including the one that explain how you do the partial fraction decomposition. And you know what? I will put the link to that video on the description of this one. Okay? So let's solve that equality. So this will become, let's do a common denominator on the right-hand side of my equality. So u2 plus 2 divided by u plus 1 times u square minus u plus 1. The common denominator here on the right-hand side become u plus 1 multiplied by u square minus u plus 1. And I have to multiply my a by u square minus u plus 1. And my bu plus c, I have to multiply it by u plus 1. Now that I have the same denominator on the left-hand side and on the right-hand side of my equality, I can get rid of my denominator. So it become u square plus 2 equal, and let's develop the right-hand side. A times u square is au square minus au plus a plus bu square plus bu plus c. Yeah? And now let's factor out the one with the same variable on the right-hand side. So my u square plus 2 is equal a plus b multiplied by u square. And here I have u, and I have c times u is cu, and c times 1 is c. Yeah. So here bu times u is b squared, bu times 1 is bu, c times u is cu, and c times 1 is c. So now let's factor out the one with the u. I would like to start with the positive one, so I would put b plus c minus a with u. So those goes, and I still have a plus c plus a plus c. I'll put it here. And this is u squared, because au squared and bu squared, so I have to factor out u squared. So if I look at the coefficient of u squared on the left hand side, it is 1, and on the right hand side is a plus b, so I can conclude that my a plus b is equal to 1, and b plus c minus a on the right hand side has a coefficient of u, but I don't have any coefficient of u on the left hand side, so my b plus c minus a is equal to 0, and the one that does not have a u variable is a plus c on the right hand side, and it is 2 on the left hand side. So from this I can conclude that my a is equal to 1 minus b, or my minus a is equal to b minus 1. So this is my formula 1, my formula 2, and my formula 3. From formula 1, I know minus a equal b minus 1. I put minus a because I have minus a in formula 2. So if I go to formula 2 now, and I have b plus c, and instead of minus a here, I can write b minus 1. Plus b minus 1 is equal to 0. So here I would have 2b plus c is equal to 1. Okay? And if I go to formula number 3, which is this, I have a plus c equal to 2, but I know that my a is equal 1 minus b. So 1 minus b plus c is equal to 2. So my c is equal 2 minus a plus b, 2 minus 1 plus b. So my c is equal 1 plus b. And now if I want to replace my c in that formula here, so I would have 2b, and instead of c I would write plus 1 plus b is equal to 1, because I'm replacing it here. So I have 3b plus 1 equal to 1, the 1 and the 1 disappear, so I would have 3b is equal to 0, that means my b is equal to 0. And if my b is equal to 0, I come here, I know a equal 1 minus b, so my a is equal 1 minus b, a equal 1 minus 0 is 1. And formula number 3 here, with a plus c is equal to 2, and I know a is equal to 1, so 1 plus c is equal to 2, that means my c is equal to 1. So my integral, the original integral here, become this one here. My a is equal to 1. We just calculated. My a is equal to 1. My b is equal to 0. My c is equal to 1. So my integral become the a is 1 divided by u plus 1 du, plus my b we said is equal to 0. I have b u plus c. So 0 times u is 0 plus c is 1 divided by u squared minus u plus 1 du. And I know that integral here is equal ln of u plus 1. So this, the integral of 1 divided by u plus 1 du is equal ln of u plus 1 plus c, and I know u, we said u is equal to tan of x. So it is equal to ln of tan of x plus 1 plus c. So this I will highlight it because I will add it at the end, and I will work on this part of my my integral. So that integral, and now I will work on 1 divided by u squared minus u plus 1 du. And if I look at it, it looked like u minus 1/2 square, because 2 times 1/2 times u is minus u. Minus 2 times 1/2 times u is minus u and u square. But here I have to work with the one that is here. I have to work with the one that is here. So if I have u minus 1 square minus half square is equal u square minus 2 times u times 1/2 is minus u plus 1/2 square is 1 over 4. But I want the 1 over 4 to become 1. So I add to it 3 divided by 4. So my denominator here become 1 divided by u minus 1 over 2 square plus 3 divided by 4 du. So now I want to solve this. Here I say let v equal u minus 1/2. So my dv is equal to my du. So I will have here the integral of 1 divided by v squared plus 3 divided by 4 dv, because my dv is equal to du. Here I know that I have a formula, integration formula. The formula is the integral of 1 divided by x squared plus 1 dx is equal the one that is here times arc tan of x plus c. So that's a formula I will highlight it. So now I want my integral here to resemble to this formula. So that's easy. I can take 3/4. I factor out 3/4 in my denominator. So my integral become 1 divided 3 divided by 4 v squared divided by 3 divided by 4 plus 1. dv. So now I want to work on this to make it v squared. Yeah. So I take my v squared divided by 3 divided by 4. It's equal v squared times 4 divided by 3. So it is equal 4 v squared divided by 3. So it is equal 2v divided by square root of 3 square. But because I don't like, nobody like to see square root in the denominator, it become 2v divided by square root of 3 times 1. But the 1 I want to write it as square root of 3 divided by square root of 3 and all that square. So it become 2 square root of 3v divided square root of 3 times square root of 3 is 3. So that would be my v squared divided by 3/4. So my integral here become, actually 3 divided by 4, I can take it outside my integral. It become 4 divided by 3, because it's 1 divided by 3 divided by 4, become 4 divided by 3. 1 divided, instead of saying v squared divided by 3/4, I want to say this. 2 square root of 3v divided by 3 square plus 1 dv. Now I can take my w is equal to square root of 3 divided by 3v. So here I say let w is equal to 2/3 times square root of 3v. So my dw is equal to 2/3 square root of 3 dv. So my dv is equal 3 times dw divided by 2 square root of 3. And again, we don't like to see square root in the denominator. My dv is equal 3 divided by 2 square root of 3 multiplied by 1, but my 1 I want to write it in an intelligent way, which is square root of 3 divided by square root of 3 times dw. So my dv, 3 times square root of 3 is equal 3 square root of 3 divided by 2 times 3 is 6 dw. So my dv is equal square root of 3 dw divided by 2. So my integral, that integral here, become 4 divided by 3, 1, and this here is equal this, which is w square plus 1, and my dv, my dv is square root of 3 divided by 2 dw. Yeah? So now my square root of 3 divided by 2, I can take it outside my integral. So it becomes 4 divided by 3 times square root of 3 divided by 2, 1 over w square plus 1 dw. And here I can simplify the 2 and the 4. So this becomes 2 divided by 3 times square root of 3 integral of 1 divided by w square plus 1 dw. And now I know the integral of the formula of integral. I just wrote it before. 1 plus x2 or x2 plus 1 dx is equal to arc tan of x plus c. So all that become arctan of w plus c. So this become 2 square root of 3 divided by 3 arctan of w plus c1. I'm almost done. Now I have to replace my the w by its value, and we said here w is equal to this 2 square root of 3 divided by 3v. So it becomes 2 square root of 3 divided by 3 arc tan 2 square root of 3 divided by 3v plus c, and I have to replace v by its value now. And v is equal u minus 1/2. So it becomes 2 square root of 3 divided by 3 arc tan 2 square root of 3 divided by 3. Instead of v, I can write u minus 1/2 plus c, and now I have to replace u by its value, which is tan of x. So it becomes 2 square root of 3 divided by 3 arc tan 2 square root of 3 divided by 3. Instead of u, I can say tan x minus 1/2 plus c, or c1 here. And we don't have to forget that at the beginning I have to write this now. This is equal ln tan of x plus 1 plus c. So my integral answer would become ln of tan x plus 1, I guess, or minus 1. Tan x plus 1 plus 1 plus 2 square root of 3 divided by 3 arc tan of all that. I'm gonna write it here, 2 square root of 3 divided by 3 times tan x minus 1/2 plus c. And that would be the answer for that problem. So if you like my video, please subscribe to my channel. That would help me tremendously. And I will continue doing video like this for you. And if you like this video, if you push on the like button, I would really appreciate it. Thank you for listening.